So, this further we can write as 1 by C delta k 0 square. So, dA by A divided by this we can write as ln log, you can say A by AF, correct, or the limit varying from A0 to AF. This we can further write as 1 by C delta k 0 to the power m A0. So, this is actually log A0. Okay. So, this is delta k square root of A by A0, this you should keep it in mind, this is actually log A0. This is actually, so NF is equal to integration of A0 to AF dA by C delta k0 square root of, you can say, A by A0. This we have already, so this AF should be A0. So, here this will be, you can say, ln, you can say A by A0 minus ln 1. Here log and what is called ln, both are generally both you can use. Okay. So, here this we can write as 1 by C delta k 0 to the power m means 2 square, here ln to the power A by A0. So, this relationship here I have already shown, you can see this relationship here, this is equation number 3, this is equation number 4. In equation number 4 itself I have shown, if what it is called m is equal to 2, then what should be the solution of number of cycle, this you should keep it in mind. So, here you see these are the different cases, what it is called, if y is a constant, that means if delta k is a constant, that you can say, then what happens, your y is also not a function of A. Then what happens, for this case I have shown the solution in previous case 1, and case 2, if y is varying with you can say, if y is a function of ya0, if y is a function of initial crack length, at that times delta k is also a function of initial crack length, that you can say. And where delta k is varying with, let us consider delta k is varying with crack length A. In dA by dN, what we have shown, in dA by dN log versus log del sigma k. So, here we have seen, that means in Paris law region, you see with respect to, you can say, delta k, dA by dN is varying, it is not constant. That is why we consider delta k is a function of, let us consider its crack length A, that is why we consider delta k 0 square root of, you can say, A by A0. If it is a function of this, delta k is not a constant value, if it is a function of crack length A, which you can observe from this curve also. This is the zone 2, you can say, where Paris law, there we observe that delta k equal to delta k 0 square root of A by A0. For this case, what should be the solution, that I have already shown. So, here we have observed that for m not equal to 2, that means if m greater than 2, that you can say, then what should be the solution, and for this case if m equal to 2, then what should be the solution. So, by this equation generally what we can do, we can find out the number of cycle using Paris law, if we know this initial crack length and final crack length. So, here now we are going to show how the crack length generally affect if the stress magnitude varying, and how the crack length affect if the number of cycle varying, that I am just showing here. So, here one things you can observe that for different you see stress value, you can observe that, like for this is for sigma 1 stress value, you can observe that here the crack length is varying like this. Now, if stress value varying amplitude varying, that is sigma 2, then how the crack length varying. This is for sigma 2, and for sigma 3 you also observe that how the sigma 3 how the you can say crack length, this axis represent this ordinate represent crack length and this is number of cycle. So, what we observe that for a particular stage value, if the number of cycle increase, then the crack length increase, that you can observe. If the number of cycle increase, then the crack length increase. Like for a particular stage sigma 1 you can observe that, and another things also you can observe that if the number of cycle increase, then rate of change of crack length also increase. Crack length increase as well as if the you can say if the number of cycle increase, then what we observe that here slope also increase, because initially the slope was like this. So, you see this slope is also increase if the number of cycle increase. Slope increase means rate of crack propagation also increase, this you can observe, because you see here the slope is like this, that this is our theta 1. So, in this case the slope is theta 2, in this case. So, here you see theta 2 greater than theta 1. Similarly, let us another theta here, in this case let us consider we got theta 3. So, here theta 3 greater than theta 2. So, you see this slope is also increasing. That means, you can say crack propagation rate increase with increase of number of cycle, that also you can observe from here. Okay. So, what you can observe from this relationship, that for a particular stress value or stress amplitude, you can say your you can say crack propagation length increase, what it is called, if the number of cycle increase first, and rate of crack propagation, that means rate of increment of the length, or you can say slope is also increase if what is called number of cycle increase. That means, what you observe that if you see sigma 1 greater than sigma 2 greater than sigma 3. So, you can say the critical crack length is less, you can say the critical crack length is less, or you can say the critical number of cycle or failure number of cycle is less if the stress amplitude is more, that you can observe. So, for sigma 1 you see your number of cycle is this, let us consider N1 F. If this sigma 2 is less, then you see your number of cycle is definitely, this is normally should happen. So, number of cycle is N2 F. So, here one thing you should keep it in mind, this N2 F is greater than N1 F. Why? Because here always you should keep it in mind, here sigma 1 is greater than sigma 2, because higher the stress level, lesser will be the fatigue life, this you can say. So, from this relationship you can observe very interesting thing. So, you can observe, that means this rate of change of crack propagation with respect to number of cycle is not constant for all level of stress. For varying stress, this dA by dN also varying, and dA by dN also varying. What happens if the crack length also vary? You see, if the crack length increase for a particular stress cycle, if the crack length increase, then you can say your dA by dN also you can say increase, that way you can say. That means, crack propagation rate also increase from for a particular number of cycle, that you can observe, because dA by dN you can say is increase if the crack length A increase, that way also you can say, because this slope is increasing, correct, this you can say. So, from this relationship you can get a very interesting information, that means this crack propagation rate is not constant throughout the entire number of cycle. If the number of cycle increase for a particular stress level, then you can say your crack propagation rate increase. This way you can say, that is why I have written this crack propagation rate generally increases with increase of stress 1, and crack growth also increases with crack length A. If the crack length increase, this crack growth rate also increase. This you should keep it in mind. So, this is a very interesting relationship. Apart from these things, also you can observe that this crack growth rate also depends on what is called stress ratio. This you should keep it in mind. Like what happens for a particular log you can say dA by dN. For this generally you can say, if we draw what it is called crack propagation curve, you can say crack propagation curve for different stress ratio, for different stress ratio. What is stress ratio? You know this thing, stress ratio R is equal to sigma mean divided by, you can say, sigma max. This you should keep it. So, R is equal to stress ratio, how it is varying. So, it is observed that if the stress ratio vary, then what happens, your crack propagation rate also varies. It is observed that if the stress ratio increases, then what happens, your crack propagation rate also increases. How it is, that I am just showing. It is observed, let us what happens, I am drawing two curves, crack propagation curve for two stress cycle, So, this is our you can say critical or fracture point, this 1 and 2. So, always you should keep it in mind this threshold value. So, this is generally called delta K TAs, and this is also another delta K TAs. So, this is let us for curve 2 and this is for curve 1. Let us consider this is curve 1. So, let this is our curve 1, this is curve 2. So, here always you should keep it in mind, let us this curve 1 is for stress ratio R1 and this curve 2 is for stress ratio R2. Always you should keep it in mind this, if the stress ratio increase, here always you should, if here R2 greater than R1. If the stress ratio increase with the crack propagation rate with respect to number of cycle, it is increase, what I am telling, understand. And for high stress ratio, you can say for higher stress ratio, your threshold value of threshold value of stress intensity factor range is lesser, this you should keep it in mind. That means here delta K, this is actually threshold value. I have already discussed in details about this threshold value of stress intensity factor range. This also you should keep it in mind. That means your this threshold value of stress intensity factor is definitely, it is generally less in case of higher stress, higher you can say stress ratio, that means R2, whereas threshold value of stress intensity factor range is higher if the, you can say, stress ratio is lower. This you should keep it in mind. So, these are the some important information related to fracture mechanics we should know. Now, we will solve one problem based on this Paris law, then it will be very clear to us. Okay. So, some problem we will solve. First of all, one problem I am just solving, then another problem also, if time permit, I will solve. So, the problem statement is like, you can see, a welded specimen made of high strength steel plates which has a fracture toughness of 80 MPa square root of m. So, what are the given information? So first of all, fracture toughness is given. Fracture toughness means KIC, critical stress intensity factor, is given as 80 MPa square root of m, because we know this relationship. So, another things is given as, so this welded specimen is subjected to alternating load which have a tension value. So, you can say sigma max tension value is given as, this is in tension is 50 MPa and a compressive stress value of 60 MPa. So, sigma mean which is compressive, that is also given, that is minus 60 MPa, you can say, this is compressive in nature. This you should keep it in mind. One thing you should keep it in mind, generally compressive stress is not contribute any stress intensity factor, this you should keep it in mind. So, generally compressive stress never help to propagate the crack, correct. So, that is why compressive stress always will be considered as not to effect on stress intensity factor value. Okay. So, if there is will be any compressive value, stress value, that stress value will not have any effect on stress intensity factor, this you should keep it in mind. So, here the plate is survived for 10 years with stress being applied at the frequency of 1 every 5 minutes. So, what we need to find out, the plate is to survive for 10 years with the stress being applied at a frequency of 1 every 5 minutes. So, every 5 minutes there will be a stress cycle. If the plate is subjected to like this, then what happens for 10 years, actually it need to survive, that is given. So, what are the things given? So, here you can say time interval for one cycle, equal to 5 minutes is given, and this plate need to design, this welded plate need to design for 10 years, this you should keep it in mind. Okay. So, here we need to assume that the geometry factor, so here geometry factor y is considered as constant value, that is 1.12, okay. And we also assume here it follows the steady state equation, that is Paris law, dA by dN C delta k to the power m, where C is equal to generally given as 1.62 into 10 to the power minus 12, and m is given as, so this C has a value, this is actually, this is meter per cycle, and m is equal to, you can say 3.2, these are the value is given. Okay. If it is given like this, then what happens, we need to find out what? We need to find out maximum allowable initial flow. So, we need to find out what is the initial flow length A0, that means A0 we need to find initial plus size, or you can say this is also called initial crack length, This initial crack length we need to find out based on this information. So, what are the problem statement? So, problem statement is like this: a welded specimen made up of high strength steel plates. This welded specimen is subjected to what it is called a alternating load of tension is 500 MPa and compression to 60 MPa. this plate is to survive for 10 years with a stress being applied at a frequency of 1 every 5 minutes. So, 1 every 5 minutes if it is subjected to for 10 years, what should be the final number of cycle? That fatigue cycle I need to find out first. Okay. Now, assume that the geometry factor y equal to 1.12 is given, m is given equal to 3.2. So, we need to find out what was the initial crack length of that welded specimen, that we need to find out. Okay. So, based on this information we need to find. So, first of all what we need to find out, if the welded specimen subjected to what is called one cycle for 5-minute interval, then in 10 years what should be the number of cycle, that means fatigue cycle, what is the number of fatigue cycle, that I am going to first find out. So, here we have 10 years equal to, we can find out in terms of minute. So, 10 years 10 into 365 days you can say. So, 365 days. So, 1 day is equal to, you can say 24 hours and 1 hour is equal to, you can say 60 minutes. So, this will give us what it is called, this will give us the total number of, this will give us total number of minute. So, what will be the number of cycle? So, number of cycle NF we can write as, so 10 years, that means this 10 into 365 into 24 hours into 60, and one cycle time interval is 5 minutes. So, this if you divide we can find out what is the final number of cycle for 10 years. So, this welded specimen will be subjected to a fatigue cycle, which is, if we just calculate these things we will get, this is equal to your 10512 number of cycles. So, this is the total fatigue cycle. So, we got this NF value. Now, we know what it is called, here stress intensity factor KIC is given. So, KIC is given as 80, what it is called, MPa square root of meter. So, this is equal to, we know what it is called, we know y, you can say del sigma square root of pi a critical length, or you can say a final length. Okay. This a final length we can easily find out from this equation. So, here what we need to do, we have given this y value, what is del sigma. So, del sigma always you should keep it in mind, I have already told you here del sigma equal to, you can say sigma max minus sigma min, but always you should keep it in mind, if any stress value is compressive in nature, that compressive stress will not contribute any stress intensity factor. So, here sigma m is 60 MPa, which is compressive. So, this will not contribute any effect on del sigma k. That is why here always you should keep it in mind, here del sigma should be this sigma max, which is the tension stress, this that del sigma min, as it is compressive it will not contribute any effect on what it is called stress intensity factor. That is why here del sigma will be only 500 MPa, this you should keep it in mind. This is a very important point, you should keep it in mind. Always you should keep this thing in mind, if there will be any compressive stress, that will not contribute any effect on stress intensity factor. So, that effect should be 0. I have already told you, because compressive stress is not help to propagate the crack, what I am saying, it is help to close the crack, that you can, that is why what happened, its effect in propagation will be 0. That is why we are not considering compressive stress effect on stress intensity factor. So, that way generally we will find out. So, y is given as 1.12, Del sigma is, I have already told you, it is 500, only tension part we need to consider, square root of pi into AC. So, from here we can easily find out so 80 equal to these things. So, from here AC we can find as, directly I am showing AC equal to, you can say 0.00649 meter. So, this is the AC, or you can say this is the, so AC value equal to 0.00649 meter, final crack length, AF, AC or AC, whatever it is. What I am telling, understand? Now, we need to find out, so we got this AF value. Now, we need to find out what is the initial crack length, A0. So, our main aim, we need to find out what is the initial flow size. This is our means this problem requirement. So, for finding out A0, we need to use here NF solution of the, what it is called Paris law. That is actually, you can say that I am directly writing here, NF 1 divided by C, okay, del sigma pi y whole to the power, you can say m, into 2 divided by 2 minus m, AF to the power 2 minus m divided by 2 minus A0 to the power 2 minus m divided by 2. So, this equation actually I have already shown how it is coming for a constant y value. Here y value is given as constant, m value is given as also constant, that is why this we are using this equation. So, in this equation what we will get? So, we will, if we will put the value 1 by C, here C value is given as what are the value, C value is given 1.62. So, that I am writing 1.62 into 10 to the power minus 12 into 10 to the power minus 12 meter per cycle. So, it is this into 1 divided by del sigma, already I have told, that is 500 into a square root of, so 500 to the power m is given as 3.2 I am putting, and also given pi to the power, you can write pi to the power what, directly I am putting this thing, pi to the power 3.2, because a square root of pi is there, 3.2 divided by 2, and here y is also given. So, y is given as 1.12 whole to the power, what it is called, m means 3.2, okay, and this 2 divided by 2 minus m is given as 3.2, and here this AF is already calculated, that is actually 0.00649 whole to the power 2 minus 3.2 divided by 2, okay, minus A0 into this A0 we need to find out, A0 to the power 2 minus 3.2 divided by 2. If we put, then what we will get, just you solve these things. So, here NF is given as, so here NF is given as, here I am directly putting. So, here NF is given as, already given, not here we have calculated 1051200 number of cycle, this is given as this. So, based on by solving this equation, let us what happens, this is equation number A. what we get? We get A0 equal to, directly I am writing, you will get 9.9526 into 10 to the power minus 7 meter. So, what we got? So, initial flow size we can easily find out with the help of what it is called, this Paris law equation. So, what we observe here, for a particular number of cycle, and if it is generally this stress intensity, this fracture toughness, this is a input value of a particular types of you can say component. So, this stress intensity factor is given and material constant also, that things if we know, then with the help of this Paris law, what should be the initial flow size, so that it can subject it to a particular number of cycle. What I am telling, understand, to fracture, that related information we can get. So, if one input is given, then other output we can get. If output is given, then input also we can find out what it is called with the help of this Paris law. So, this is a very what it is called interesting, you can say, approach, and which have a wide acceptability in the field of, you can say, fatigue life prediction with the help of this what it is called Paris law in fracture mechanics approach. This is called linear elastic fracture mechanics approach. So, here one important things we need to know, this stress intensity factor or you can say fracture toughness, how we can calculate, that also we need to know. Generally, this fracture toughness we can find out with the help of different types of experimental approach. How it is, that I am going to show. Like this stress intensity factor, we can find out some of the approach I am showing, like penny shape crack, which is subjected to what it is called tensile stress sigma. For this case, this stress intensity factor in mode on can be represented as you can say like this, 2 sigma square root of a by pi. Similarly, using 3-point bending test, also we can find out this stress intensity factor Ki. So, 3-point bending you know very well. Why it is called 3-point bending? Because it is subjected to 3 point types of loading, you can say, 2 support, this is one support, this is another support, you can say let this is A, B support, and it is subjected to a load P. This P in opposite side of the P, this crack we generally developed, let us with a crack length A. Okay. Now, with the help of this 3-point bending test, as in this case the load is acting transverse to the what is called a specimen, that is why what happens, it is also called what is called bending operation. So, it is also called we know that the definition of beam definition is once the load is acting perpendicular to the axis of that specimen, that is generally called beam. So, this is also a you can say crack beam, which is subjected to a load like this. If it is subjected to load like this, and if it will have a dimension of as per specification like B, W, 4W, then what happens, with the help of this following equation we can find out what is mode on stress intensity factor, and with the help of this mode on stress intensity factor at fracture level what should be the Ki, from there also we can easily find out what is the KIC, that means critical stress intensity factor, or you can say fracture toughness. This you should keep it in mind. This is another approach, this is called 3-point bending or beam bending test. And another approach also we can use, that is generally a plate with you can say slanted crack, that is means inclined crack, which is subjected to biaxial state of stress. Biaxial means both the direction the stress is applying. So, for this case generally this mode on stress intensity factor and mode to stress intensity factor can be represented like this by using this equation, where beta is the angle of this crack with respect to the horizontal axis, you can see. So, with the help of this equation we can find out what it is called what is the mode on and mode to stress intensity factor. And another very important critical stress intensity factor or you can say fracture toughness estimation procedure is called CTA specimen test, or you can say it is also called compact tension testing. So, in compact testing the specimen details is given here. So, this dimension generally according to some STM standard. So, we need to follow this standard. Here generally this whatever the specimen detail is given, so according to this we need to make the specimen and we need to make this initial crack also. So, after that if it is subjected to what is called tensile types of loading, that is mode on types of loading, that for that case generally what should be the critical stress intensity factor. With the help of this load versus you can say crack length plot, we can easily find out the critical crack length as well as critical stress intensity factor, or you can say fracture toughness. So, these are the references which I have followed for this lecture. Thank you.